Question number 2C, we're given the rational expression 3x squared minus 5x minus 2 divided by x minus 1. So we have a quadratic function in the numerator, a linear function in the denominator. That means that we're going to have a slant asymptote. When the degree in the numerator is 1 higher than the denominator, the asymptote is a slant asymptote. So we're going to find the vertical asymptote first. The vertical asymptote is going to be from the denominator, so it's going to be at x equals 1 or x not equal to 1. So I'm just going to draw that in here. We have our zeros. Our zeros are going to come from the factored form. So 3x plus 1 gives us a 0 at x equals negative 1/3. And x minus 2 gives us a 0 at positive 2. To get the y-intercept, we just plug 0 into the expression. If I plug 0 into this original expression, I get negative 2 divided by negative 1. So we get a y-intercept at y equals 2, positive 2. So I'm just going to draw on my zeros. I have negative 1/3 at positive 2. I've got a 0, and I've got a y-intercept at positive 2, maybe somewhere around here. To get the slant asymptote, what we do is we do the long division. So as I do the long division over here to the right, my quotient is 3x minus 2, and then I have a remainder of negative 4. So 3x minus 2 then represents y equals 3x minus 2 is my slant asymptote. So I'm going to have an asymptote that goes through like this, so minus 2, so maybe something like that. Okay, and I have my coordinates that I found from the rest of the equation. I have a coordinate here, here, and here. So it has to follow the asymptotes. It's got to go through those coordinates. So it's going to look something like this. Going to follow those asymptotes, come through the coordinates, and follow the asymptote like that. And on this side here, it's going to follow the asymptote like this. It's going to go through the 0, and it's going to follow the asymptote. And so we're going to have a graph that looks like this. Okay, so the slant asymptote here, I'm just going to write it down, is y equals 3x minus 2. So looking at the next one here is a very similar equation. The difference is we have a minus 5x over here. This one is a plus x, but it does make a difference in a number of things. So we're first going to start off with the vertical asymptote. The vertical asymptote of this graph is going to be the same. It's going to be at x equals 1. Okay, so there's my vertical asymptote. My zeros, I have to factor it. So when I factor it, the factored form is over here. So 3x minus 2, x plus 1. So I have my zeros are going to be at x is equal to negative 1 and positive 2 over 3. When I substitute in my 0 for the y-intercept, x equals 0 for the y-intercept, I get y equals 2. So very similar. I have 0 now at negative 1 at 1/3 here. I've got a y-intercept maybe up here at 2. Okay, now I need a slant asymptote. My slant asymptote I get from my long division over here in red. So x minus 1 into 3x squared plus x minus 2 gives me a quotient of 3x plus 4. That's my slant asymptote. And my remainder is positive 2. So 3x plus 4, I'm going to draw something like this. Okay, so I end up with my graph following my asymptotes, goes through the 0, goes through the y-intercept, goes through the other 0, and then follows the asymptote like this. Now, although we have no coordinates in this part, we know that the graph is going to follow the asymptotes in that top right-hand quadrant there. So those are the two parts of the graph. And if I compare those two graphs, they're slightly different in that when I have this one here is going on the kind of outside diagonal. Okay, so along this diagonal, whereas the other one goes through that diagonal. And the difference is going to be, we can always find this by plotting the points and following the points. However, we could also anticipate this based on the remainder. So this is what the these points down here are. So the graph, these two equations are different in just the quadrants that the graphs fall in. So if I draw my quadrants here like this, I'm just going to maybe choose a different color. If I draw my quadrants like this, if I have a positive remainder, so in the case of red, I have a positive remainder over here, we end up along the positive diagonal. The graph ends up along that diagonal with positive slope. So if I go across the diagonal there, that line has positive slope. The blue graph, the original one, has a remainder of -4. Well, then that follows a negative diagonal. And although the coordinates forced me to this diagonal here, if I look at that diagonal there, that is a negative slope diagonal. Okay, it goes through the negative quadrants like that. Okay, so our remainder allows us to anticipate which quadrants between the asymptotes that we're going to draw our graph. It's either going to be in between this, along that diagonal, or along this diagonal. If we take a look at the red graph, the positive remainder tells us it's along this diagonal, and the negative remainder would go along that diagonal there. So this is redundant information in that we don't really need to know that the remainder puts it along that diagonal, but we can use that remainder to help us kind of confirm that we're in the right quadrants when we draw our graph.